Alright, I'm going to page 3 of 7.3, where we're going to, instead of doing transform on the s-axis, we're going to do transform on the t-axis, meaning we're going to transform the original function. Instead of transforming the s function, we're going to transform the t function. And so, something that's going to be used frequently in engineering, so those of you who are going off to engineering, you're going to be seeing this again. Those of you who are majoring in math, you might not even see this again. But it's going to be the unit step function or the Heaviside function. And see, what these functions do is they turn either something on or off, meaning that, you're not going to, this is going to allow you to, plug in a function or have a function that's not going to, come into play until you reach a certain value for whatever your a is. And so we define a special function that is the number 0, which means off, to a certain time, and t equals at a certain time t equals a, and then number 1 on after that time. So 0 is off, 1 is on. And so pretty much what happens is our function isn't going to start until our value for t reaches a. So it's a way to cut off our function. So anytime you see a function t times this u, which is in cursive, of t minus a, we have a Heaviside function or a unit step function. And so that means that this function is not going to start until t reaches a. And so as long as t is a value that's less than a, it's 0. But once t reaches that value of a, then this function is 1. Alright, so say like if a was 5. If a was 5, this function does not come into play until u reaches 5. And once u reaches 5, then hey, now this function can be turned on because this value is 1. And so now we're just dealing with this function. So anytime you see the unit step function, it's either 0 or 1. Alright. So example 7 is we're going to express the following function in terms of unit step functions. So here we're starting at 0, and what's our starting value is 2. So our function f of t is going to start at 2. And then once we reach 1, our function is going to go to positive 1. So we're going down a step of 1. Now, this minus 1 will not come into play until our unit step function reaches 1. Once it reaches 1, then it's cut on, and this minus 1, because this value is 0 until we reach 1. Once this hits 1, then this will always come into play of this minus 1. So we're 2. Once we hit 1, we're going down to positive 1, because 2 minus 1 is going to be positive 1. And then we're positive 1 until we reach 2, and then we're back up to 2. So we should add 1. And we don't add this 1 until our t reaches a value of 2. And so here we have a unit step function that does that. Once we reach the value of 2, this now comes into place. This is always this is 0 until t reaches 2. Once t reaches 2, then hey, this is 1. So then we can use it. And then at the very end, our function goes down to 0, so we went down 2. So this minus 2, and this minus 2 doesn't come into play until t reaches 3. Right. And so this minus 1 and this plus 1 can be written that way as well, without the minus 1 and the plus 1s. Alright, now, the unit step function can be used to write piecewise defined functions in compact form. So, for example, say we have f of t, and g of t is not going to be, g of t is what we're going to start off with until we reach a, and then once we reach a, we're going to go into h of t. So we can write this way. We're g of t, and then we're going to take away g of t once t reaches a. So here, whatever g of t is, then once it reaches a, this is all 0 because those two values are going to be the same. And then this is when h of t is going to cut on. And so we have the u of t minus a. And so then we're h of t once t reaches a. So, for example 8, write in terms of unit step functions. So here we have two functions, t squared and 0. So f of t is going to be, we're going to start off with t squared. So we're t squared up until we get to 2. And so this function is going to be t squared up until we get to the point of 2. And so this tells me that, I'm not going to subtract t squared until I reach 2. So that's what the unit step function tells me. And so once we reach 2, I now have t squared minus t squared plus, and then 0 cuts on at my unit at when t reaches 2. And so therefore, I'm just going to be 0 after 2. And so I don't need this part because 0 is going to stay 0 if I have it here or not. And so t squared minus t squared times u of t minus 2 is going to denote this piecewise defined function. Alright, now the last things to consider is this translation on the t-axis. So f of t minus a times the unit step function of t minus a, or u of t minus a, or cursive u t minus a, is equal to 0, and then f of t minus a when we're 0 to a, and then when t is greater than a. So basically what we're doing is we're taking whatever function we have and we're shifting it over to a. So it's not, we're changing its starting point. So instead of starting at 0, we're going to start at whatever the a value is to cut our unit step function on.